Hey guys, in this video we're going to be taking a peek at a little bit more trigonometry inside of, non-right angled triangles. So in particular we're going to be looking now at finding the area of these triangles, and it's probably much nicer than the sine and cosine rules. So the formula for it is this chap down here, 1/2 AB sine C, but to be honest I think it might be one of those classic cases where a formula complicates things. So let's get cracking and have a look at what we're going to be doing. So before we look at using trigonometry to find areas, I just want to point this out. It seems to be a very common misconception. 1/2 times the base times the height is the formula to work out the area of any triangle. It doesn't have to be a right angled triangle. It works for any triangle where we know the base length and we also know the height. Now the problem we're facing in this video is that we don't necessarily know both of those two lengths. So it's trigonometry to the rescue. But again, 1/2 base times height works for any triangle you ever come across as long as you know the base and the height. Okay, let's get cracking then. Okay, so question 1. So here we do know the base length of our triangle, but we don't know the height. So we're going to have to use the trig formula. Now let me just write that down. So the area is 1/2 AB sine C. Now at the moment my triangle doesn't have any labels on it. So as I said, I think sometimes the formula complicates this. So all that we're doing, if we have a triangle where we know side, angle, side, so for example this 10 centimeter is one of our sides, then we know the angle in between them, and then we know another side, all that we are doing 1/2 times one of the side lengths times the other side length times sine of the angle. So if you like, we could put our trig labels on here. So let's give it a SAS. So we could call the 10 centimeter side A, and the 8 centimeter side we could call B, then we could call the angle C. So as with the sine and cosine rules, if you don't like the labels that you're given, or if you're not given any labels, put your own labels on the triangle if you want to, and label it so that it fits in with the formula that you are most familiar with. Okay, so let's work it out. So we are doing 1/2 times 10 times 8 times sine of 30. Now if you put that into your calculator, obviously it will tell you the answer. Let's have a go doing it without those. So 1/2 times 10 is 5. So then we've got 5 times 8 times sine 30. Now sine 30 is one of our standard trig values that we're supposed to know. Sine 30 is equal to 1/2. So we've got 5 times 8 times 1/2. Now 5 times 8 is 40 times 1/2 gives us an area then of 20 centimeters squared. Okay, so again, just to reiterate what we've done, 1/2 times one of the side lengths times the other side length times the sine of the angle, or in terms of a formula, 1/2 AB sine C. Okay, on with the next. Okay, so we have a similar sort of setup here. We've got one angle and we know the two side lengths coming out of it. So if you like to think of this in terms of the formula, we can label this A and the 7 centimeter side B, or the other way around, of course, it does not matter at all. Then the angle is C. So the formula, 1/2 AB sine of C. So again, all we're doing, 1/2 times the side length times the other side length times the sine of the angle. So plonking that into the formula, we get 1/2 times 9.6 times 7 times sine of 50 Now sine of 50 is not one of our standard trig values, so it would definitely be time to turn to your calculator. Now if you put that in, then to one decimal place, you will get the area is equal to 25.7 centimeters squared. Jobs are getting. Okay, on with the next. Okay, similar setup again. We've got an angle, we know the two side lengths coming out of it. So, if you like to label, let's call the 6 centimeters A, 12 centimeters B, and then of course the angle C. Okay, so we just plonk our numbers into the formula. So we get 1/2 times 6 times 12 times sine of 23. Now again, sine of 23 is not one of our standard trig values, so we would need our calculator. And if you plonk that in to one decimal place, you will get the area as 14.1 centimeters squared. Jobs are good. Okay, we're going to do one more. Okay, now then, in this question, we've got a slight hitch. We've got two angles inside our triangle, we've got two lengths inside our triangle, but we do not have the angle between our two lengths. Luckily though, we can work that out. So if we add 150 together, so 100 degrees at 50 degrees, that gives us 150 degrees. So to work out this chap here, we do 180, take away 150, and that gives us an angle of 30. So now we're happy because now we know an angle with two side lengths coming out of it. So let's call the 4 centimeter side A, the 8 centimeter side B, and the angle C. Then let's write down the formula one last time. 1/2 AB sine C. So we're doing 1/2 times 4 times 8 times sine of 30. Now we can do this one without a calculator because sine 30 again, it's one of our standard trig values. So let's do 1/2 times 4. Well, that's 2. So we've got 2 times 8. Now sine of 30 again, remember, is 0.5 or a half. So we've got 2 times 8 is 16. And then 16 times a half gives us 8 centimeters squared. Jobs are getting. Okay guys, so that's how we find the area of triangles using trigonometry. Hope it's helped. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.